Good morning everyone. I welcome you all to today's programming in C class. In today's session, we are going to learn one of the most important concepts in C programming, namely one-dimensional array. Before learning arrays, we have already studied variables, data types, operators, input and output statements and control statements. These concepts are the foundation of C programming. Today we are moving one step further by learning arrays, which help us store multiple values efficiently. Arrays are used in almost every programming language and they are very important for writing efficient programs. Whether you are developing software, mobile applications, embedded systems, or engineering applications, arrays are widely used. Before understanding what an array is, let us first understand why we need arrays. Suppose I ask you to write a C program to store the mark of one student. It is very simple. We can write int mark equal to 85. Here the variable mark stores one value. Now let us think about another situation. Suppose our class has 60 students and we want to store the marks of all the students. Can we use only one variable? No. Then what we will do? We may create separate variables like mark 1, mark 2 up to mark 60. Now can you imagine how lengthy the program will become? Not only that, printing the marks or calculating the average will also become very difficult. Instead of creating many variables, we can simply create one array. For example, int mark array of 60. This is single statement creates an array that can store the marks of 60 students. Each mark is stored in a different position inside the array. So an array is simply a collection of similar data items stored under one common name. All the elements in an array must have the same data type. For example, an integer array stores only integer, a float array stores only floating point values, and a character array stores only characters. One more important point is that array elements are stored in continuous memory locations. This helps the computer access data quickly. So whether you need to store many values of the same data type, always think of using an array instead of many separate variables. This makes your program shorter, easier to understand and easier to maintain. Now let us understand the characteristics of array one by one. The first characteristic is that an array stores elements of the same data type. For example, if we declare an integer array, every element must be an integer. We cannot store a character or floating point value inside an integer array. The second characteristic is that array elements are stored in continuous memory locations. What does continuous means? It simply means one after another. Imagine a row of lockers in your college. Locker number 1 is followed by locker number 2. Then locker number 3. Similarly, array elements are stored one after another in memory. Because of this continuous arrangement, accessing array elements become very fast. The third characteristic is that the array name represents the address of the first element. In simple words, the array name points to the beginning of the array in memory. Another important characteristic is that the size of the array must be specified during declaration. For example, if we declare int marks array of 50, the array can store exactly 50 elements. We cannot store 51st element. If we try to access memory outside the array, the program may produce incorrect results or behave unexpectedly. So always remember that arrays have a fixed size. Now let us see the different types of arrays available in C. There are three types. The first one is the one-dimensional arrays. The second one is the two-dimensional array. The third one is the multi-dimensional array. A one-dimensional array stores data in a single row. For example, storing marks, ages, temperatures or salaries. A two-dimensional array stores data in rows and columns. You can think of it like a table or a matrix. For example, storing the marks of students in different subjects. Multidimensional arrays are extension of two-dimensional arrays. They are mainly used in advanced programming applications such as graphics, scientific calculations, and simulations. In today's class, our focus is only on the one-dimensional array because it is the basic and most commonly used type. Now let us understand the one-dimensional array in detail. A one-dimensional array uses only one index to access its elements. Each element has a unique position called an index. One very important point to remember is that array indexing always starts from 0. Many beginners think indexing starts from 1, but in C programming it always starts from 0. For example, if an array has 5 elements, the indices are 0, 1, 2, 3 and 4. Notice that the last index is always 1 less than the array size. If the array size is 5, the valid indices are 0 to 4. Now let us take an example. Suppose we declare int marks array of 5. This creates an array that can store 5 integer values. Internally, the computer creates 5 continuous memory locations. The first value is stored in marks array of 0. The second value is in marks array of 1. The third value in marks array of 2. The fourth value is marks array of 3. And the fifth value in marks array of 4. Whenever we want to access a particular value, we use its index. For example, if we write marks array of 2, we are accessing the third element because indexing starts from 0. Always remember this rule because it is 1. For example, if we write marks array of 2, we are accessing the third element because indexing starts from 0. Always remember this rule because it is one of the most frequently asked questions in university exams. Now let us understand our first array program. First, we include the header file #include stdio.h. This includes the standard input-output library functions like printf and scanf. Let us we have the main function int main. Every C program starts its execution from the main function. Now look at this statement int array of 3 equal to 10, 20, 30. This line is very important. Here we are declaring an integer array named ARR. The size of the array is 3, which means it can store exactly 3 integer values. At the same time, we are also initializing the array. So the values are stored like this. The first value 10 is stored in array of 0. The second value 20 is stored in array of 1. The third value 30 is stored in array of 2. Notice something is very important. The array size is 3, but the index values are 0, 1 and 2. This is because array indexing always starts from 0. Now let us move the next part. We have a for loop. The loop starts with I equal to 0 because the first array index is 0. The condition is I less than 3. So the loop will execute 3 times. During the first iteration I becomes 0. The program prints array of 0 which is 10. During the second iteration I becomes 1. The program prints array of 1 which is 20. During the third iteration I becomes 2. The program prints array of 2 which is 30. After that the loop condition becomes false and the program terminates. Now look at the printf statement carefully. It contains two %t format specifiers. The first %t prints the value of the variable I, which represents the index. The second format specifier %t prints the value stored at the index, which is array of I. So the output becomes value of array of 0 is 10, value of array of 1 is 20, value of array of 2 is 30. This is one of the simplest programs that demonstrates how arrays and loops work together. Here another one example program. Let us now study another example. This program is very similar to the previous one, but it helps us understand arrays more clearly. Here the array size is 5. The array contains 5 values 10, 20, 30, 40 and 50. Again the indexing starts from 0. So array of 0 stores 10, array of 1 stores 20, array of 2 stores 30, array of 3 stores 40 and array of 4 stores 50. Now observe another statement shown in the program. The commands explain that instead of initializing all the values together, we can also assign values individually. For example, array of 0 equals 10, array of 1 equals 20 and so on. Both the methods are correct. However, when the values are already known, initializing the array directly inside curly braces is easier and makes the program shorter. Again, we used a for loop. Instead of writing 5 different printf statements, the loop automatically prints every element one after another. Imagine if the array contained 100 values, writing 100 print statements would be very difficult. But with a loop, we can print all the values using just a few lines of code. This is one of the biggest advantages of combining arrays with loops. Now let us understand how to declare an array. The syntax is very simple. First we write the data type, then the array name. Finally inside square brackets we specify the size of the array. The syntax is data type, array name, open the square bracket, array size, close the square bracket. For example, int mark. Inside the square brackets we write 50. Here int tells the compiler that the array will store integer values. Marks is the name of the array. And 50 tells the compiler that this array can store 50 integer values. Similarly, if we want to store decimal numbers, we can write float salary array of 20. If we want to store characters, we can write character name array of 30. So the declaration changes only according to the data type and the required size. One important point to remember is that the array size should be a constant value while declaring the array. Let us understand this declaration using a simple example. Here we have written int x array of 3. This means we have creating an integer array named x. The array size is 3. Therefore, it can store exactly 3 integer values. Internally, the computer creates 3 memory locations. The first location is represented by x of 0. The second location is represented by x of 1. The third location is represented by x of 2. Now we assign values x of 0 equals 1, x of 1 equals 2, x of 2 equals 3. Now suppose I ask you what is stored in x of 1. The answer is 2. Now another question, can I write x of 3? The answer is no. Why? Because the array size is only 3. The valid index values are 0, 1 and 2. Trying to access x of 3 means we are trying to access memory outside the array. This may reduce unpredictable results. Therefore, always ensure that the index remains within the valid range. Now let us understand how memory is allocated for an array. The formula is very simple. Total memory equal to size of one element into number of elements. For example, suppose we have int x of 3. Normally one integer occupies 4 bytes of memory since there are 3 integer elements. In total memory occupied by the array is 4 multiplied by 3, which is equal to 12 bytes. Let us take another example. Suppose we declare character name of 20. Each character occupies 1 byte. Therefore, 20 multiplied by 1 gives 20 bytes. Now, let us take one more example. Suppose we declare float marks of 10. One float generally occupies 4 bytes. Therefore, 4 multiplied by 10 gives 40 bytes. So, whenever you are asked to calculate the memory occupied by an array, simply remember this formula, size of one element multiplied by the number of elements. This is a very common question in university exams. Now let us quickly revise the important points that we have learned so far. The first point is that arrays are used to store multiple values of the same data type. Instead of creating many variables, we can store all similar values inside one array. The second important point is that array indexing always starts from 0. This is one of the most common mistakes made by beginners. If an array size is 5, the valid indexes are 0, 1, 2, 3 and 4. There is no index 5. The third point is that memory occupied by an array depends on two things, the size of one element and the total number of elements. We are calculating it using the formula total memory is equal to size of data type into number of elements. Finally, always remember that the arrays are stored in continuous memory locations. Because of this, accessing array elements becomes very fast. These are the key points you should always remember whenever you work with arrays. Now let us understand how to initialize an array. Initialization means assigning the values to the array while declaring it. The syntax is very simple. First we write the data type, then the array name. Next we specify the array size inside square brackets. Finally we write the values inside curly braces. For example, index x of 3 equal to 537. Let us understand what happens internally. The first value 5 is stored in x of 0. The second value 3 is stored in x of 1. The third value 7 is stored in x of 2. Notice that the order of values is very important. The first value always goes to the first index. The second value goes to the second index. The third value goes to the third index. This is called array initialization. Suppose I want to store the marks of 3 students. Student 1 scored 85, student 2 scored 90, student 3 scored 78. Instead of writing 3 assignment statements separately, I can simply initialize the array and the time of declaration. This makes the program shorter, cleaner and easier to read. Until now, we have stored only integer values inside arrays. Can we store characters? Yes, definitely. For storing characters, we use a character array. Here you can see the example character str of 10 equal to inside the single quotes HAI. This creates a character array name str. The array size is 10. Only the first 3 positions contain the letters HA and I. The remaining positions are automatically filled with a special character called the null character. Now, what is the purpose of null character? The null character tells the computer where the string ends. Without this character, the computer cannot identify the end of the string correctly. That is why every string in C ends with a null character. For example, the word hello is actually stored internally as HELLO. And finally, the null character. This is an important concept because whenever we learn strings in the next chapter, this null character plays a very important role. Now let us summarize today's lesson. Today we learn what an array is. We understand why arrays are needed instead of creating many individual variables. We discussed the characteristics of array. We learned the different types of arrays available in C. Then we focused on one-dimensional arrays. After that we learned how to declare an array, initialize it, access its elements, and calculate the memory occupied by an array. Finally, we understood character arrays and the importance of the null character. These concepts form the foundation for many advanced topics in C programming. Thank you for watching. Happy coding.